Okay, Tanya.
Yes, Chacha, I'm typing.
Oh, just tell us. Or you can. Oh, you are typing. Or you can just tell us which one to start with. Was that number 14?
Start with 14. No, 13.
Or 13 we have already done.
Oh, 14 then.
14. So, Shanice, can you read number 14 as Tanya is still typing?
A group of pupils wanted to compare the rate at which water rises up in soils. They set up their apparatus as shown in the diagram below. Birotube J, Birotube K, soil R, basin, cotton. Check and see the question.
Okay.
Cotton, water. From the results obtained by the pupils, the correct conclusion could not be made because
What is wrong with your microphone? We are not getting you clear.
From the results obtained by the pupils, the correct conclusion could not be made because.
Why do you think the correct conclusion will not be made?
Because they use the same type of soil.
Yeah, because there is soil R. You see now the soil R is only one soil, eh? And now we cannot compare capillarity of one soil. We have to have at least two different types of soil for us to know which one is best in capillarity. That is correct?
Yes.
Okay, thank you. Tanya, number 16. Dan Baru, pick number 16. Dan, number 16. Dan is not here. James, pick number 16. James? Yeah. James, Ida, pick number 16.
Number 16. Some pupils in primary school planted cypress trees in a nursery during morning hours. There was heavy rainfall in the evening of the same day, which exposed the seeds. To prevent the seeds from being exposed, the pupils should have applied mulch after planting.
Reason why were you supposed to do that?
Because the mulch was going to prevent the soil from being eroded, which exposed the seeds.
Okay, so it's because of soil erosion that took place. Is that correct?
Yes.
Correct. Number 17. James, pick number 17. James, pick number 17. James. We don't have James here. He's not talking. Dan Baru, can you pick number 17? Dan Baru is also not getting us. So, Tanya, read number 17.
Okay. Study 8 pupils noticed that shells that had formed on their school garden which had been prepared for planting. Which one of the following methods of controlling soil erosion should have been used before preparing the garden? The answer is A. Contour ploughing.
Reason, we are more or less not interested in the answer, but we are interested on why is A the answer.
I got wrong, but I saw that was the answer. I don't know how to explain it.
Oh, okay, you don't know how to explain. Who can explain? Why is it that choice A is correct? Who can explain that? Can I explain it?
Yes, sir.
Yes, please.
Okay. Standard 8 pupils noticed that reels had formed on their school garden, which had been prepared for planting. Now, if somebody can define for us what reel is, what is reel? Huh? What is reel? Can you define what reel is? Reel? You people, you don't know the meaning of the word reel erosion? Huh?
Small V-shaped
Yeah?
trenches.
Yeah, small V-shaped, no. What are the real erosion? How will you tell that this is real erosion, not gully? Tanya?
Just
Channels.
channels.
Very good. Small channels forming on the ground. So everybody to mute. So if real is the small channel forming on you see the small channels in the soil. So let's say this question is talking about that pupils notice that real had been formed on their school garden. Wait first. There's something that has happened. Okay. Let me look for the paper first. For the questions first. Okay, standards 8. Just 1 minute so that I get the question. Okay. So what I was saying, real is, are you getting me now?
Yes.
Yes.
Okay. So real we say are these small channels that is formed in the soil caused by, so this is what soil erosion that we are talking about. So there are those small channels. Now we are being told here in this question, number 17, that these pupils noticed that there were reels in their compound on the land that they already prepared for planting. So what can be done? Which one of the following methods of controlling soil erosion should have been done, should have been used? No, now we are not controlling real. I want you to get me clearly. We are not controlling real erosion, the one that have already taken place. The question is asking what should have been done before so that the real erosion should have not occurred. That's what the question is asking. Are you getting what I'm saying now?
Yes.
Yes.
How many people went for C? How many people went for C?
Me.
How many people went for C? Can you write on the chat if you went for C? So that I know what I'm saying people are getting. If you took choice C as the answer, can you write your name or yes in the chat? Melissa, thank you. Olivia, thank you. If there is somebody who took choice C as the answer for that question, so that we help you. I'm waiting. So there are only 2 people. The rest took which choice? Okay, Sarah, correct. Thank you. Olivia, thank you. Melissa, thank you. Tanya, thank you. Dan Barrio, thank you. William, thank you. So which choice did the rest take? Melanie, which one did you take?
Just you have written in the chat. Just see.
You took C, correct? Another person?
They took C.
C. Those who took B. Those who took B as the answer? B, nobody. So most of us took C. And the reason why you took C is because you know that how to control real erosion is through construction of terraces. True or false?
True.
True.
Yeah, meaning you know science. It's only that now you do not understand the question. So if reel is used, if terraces is used to control reel, but in this case, reel erosion has already taken place, we will have used the terraces to control it. But now these people are not asking that. These people are asking us, which method? The method that should have been done before. So what will have been done before is we should have what we call contour plowing. So can you tell me, how do I do contour plowing, Olivia? How do I do contour plowing? Olivia?
I'm not sure.
Just say what you are sure of. Contour plowing is what? How do we plant?
Contour plowing, we plant along the slope.
Along the slope. Olivia, do we plant like that? That's along the slope. Eh? Do we plant like this one? That is wrong. So we are supposed to, what are we supposed to do? Plant across the slope. So can you write that one if you do not know? Contour plowing should be done. All the best plowing to prevent soil erosion should be planting along the contours across the slope. Planting along the contours across the slope. That's what is called contour plowing, across the slope, like that one. So I plant like this. So these are my crops. So I plant them like that. I plant them like that. I plant them like that. So this is what we call planting across the slope along the contours. So contours lines are these lines that are running across the slope. So if I would have done this, then there will have been no real erosion. Agreement?
Yes.
Agreement with everybody? Yes. Can you ask a question?
Yes.
Ask it. Ask it. Is somebody who has said yes? Nobody. So everybody has understood that question. Tanya, how do I plant? How do I plant, Tanya?
So you plant across the slope along the contours.
Across the slope, along the contours. Thank you very much. So that's how we plant. Then which one again do we have? That number 17, so many people failed. So please check it. Tanya, number 18 is there. Number 18 is there. So let's read number 18, Hope. Hope, will read number 18. Hope, number 18.
Which one of the following soil conservation structures below should be constructed across and white granite control erosion?
Where are you? You are very far. Which one of the following?
Which one of the following soil conservation structures should be constructed across a deep white gully to control erosion?
Okay, so which one do you think we can take? Which one did you take? Eh?
I don't know the answer.
Okay, who can help Hope? Mute. The rest, Hope, mute. Okay, who can help Hope now? Sarah? Sarah? Shanice? Ninel? Oh, Sarah is talking, yes. Sarah?
Yes. Yes.
Which one, which number 18? Tell us what is the correct answer for number 18?
Charme road.
Cha gabion.
Reason why did you write gabion?
Cha. And the
You don't know the reason why you wrote gabion. But the gabion. Can you talk?
You prevent soil erosion. You prevent gully erosion by building gabions.
You prevent gully because the first thing you are supposed to do here is identify which soil erosion is this. Structure is what we are going to build, but which type of soil erosion is this one? It is deep, wide gully. So automatically this one becomes gully erosion. So if this one is gully erosion now, the only thing that you can use to control gully erosion is the structure, and it's also going to control. Remember, we are also being told soil conservation method. So that one become gully. There's sometimes a question come in exam asking which one can control only soil but not water. The answer still will be gabion. Gabion can only control soil erosion but not water. It will only prevent soil from passing. Correct. Tanya, do we have any number?
There's number 19 and 20.
There's number 19 and 20. So let's just do all of them. So read it, James. James, read it. Number 19.
Which
James?
one of the following farming activities will lead to soil erosion? Plowing along the slope.
So that one we have said we are supposed to do what?
Plow across.
Across the slope along the contours. Is that correct?
Yes.
I hope the person who failed there now can explain that question. Michelle, number 20.
Which one of the following activities can be used to demonstrate?
Continue.
Which one of the following activities can be used to demonstrate soil erosion? Pouring water at different positions of a slanting soil surface.
What is wrong with choice B? What is wrong with choice B? Huh? Who can help Michelle? You are continuing. Michelle is continuing. Continue. Is there?
Choice boy. In channels of soils in a slanting surface. Let somebody help me. I can't explain it.
Somebody help Michelle. What is wrong with choice boy, Stephen Levy? Okay.
It has said in channels of soil on a slanting surface. I might not be sure, but gully erosion has the deep channels, while real erosion has the shallow channels.
Why is choice B wrong? Michelle said the answer is choice A. So I'm asking the question, why B is wrong? Which soil erosion will be demonstrated by choice B?
Gully.
Fito?
Yes?
Which soil erosion will be demonstrated by choice B?
Choice?
B.
Gully.
Gully, reason?
Because let's say it's real erosion, then you pour water, it will continue to be big until it becomes gully.
Very good. I will have voted for you, Chips. Levi, you see, when we have, can you mute? We're already, if we are pouring water in channels, already this channel has already formed real erosion. So if I pour water in the channels, it will continue and now become gully. So choice B will demonstrate gully erosion.
Yeah.
Somebody's
Okay.
yeah, correct. On a flat surface of soil. Why choice C wrong, Levi?
Choice C is wrong because we are demonstrating sheet erosion by pouring soil on a flat surface.
Very good. Why is choice D wrong?
Choice D is wrong because they've said on a flat surface using a tin with many holes, and when we use that, we are going to be demonstrating splash erosion.
Very good boy. Clap for yourself. Clap for yourself for doing a nice job. Correct. So today we were supposed to continue from where we stopped. So okay. So I want to bring the questions that we are supposed to do today. So today we are supposed to do questions on weather. So be ready to answer questions for weather. So we have already remember last week we are done with we were done with the properties of matter. Is that correct?
Yes.
Yeah. So today we are starting a new topic now.
Yes.
That is weather. So somebody was having a question as I open.
Yeah, Charles, I'd like to say sorry because I never got most of the lesson. My Wi-Fi is coming on then off. I'm not that
Okay,
sure
but
why it's not.
there's no problem. What we are going to do,
Yes.
after this, you just ask a question that you have, right?
Yeah.
Yeah, there's no problem. So I want us to start from weather today. We have already done with the properties of matter. So we start from there, from the current slide, correct? So Ricky, now that you are breaking, can you start with us in number 1?
Weather and astronomy. Weather and astronomy. Be able to work out
all questions. Ricky? Ricky left. Ricky? Ricky, are you talking? Or I'm the person not talking? Juanita, are you getting me?
Sir, we can hear you.
Sir, I can hear you.
Oh, where Ricky got lost. So can you pick that question, Melissa?
Okay.
Question number 1 for weather.
When the arrow of a wind vane points to the east, the wind must be blowing to
From
Melissa?
okay. When the arrow points to where the wind is blowing from. So when the arrow is and then the wind must be blowing from east to west.
So east to west is the correct answer. Is that correct? Everybody, is that correct?
Yes.
Yeah.
Yes.
yes.
Somebody saying no? The arrow, remember the arrowhead of a wind vane points to where the wind is blowing from. So if it is pointing east, then the wind must be blowing from east to west. I think that is the correct answer, unless you have a different explanation. Number 2, Dan Baru, number 2. Dan Baru, number 2. Dan Felix, pick number 2.
I cannot see the screen.
Okay.
Which one of the weather instruments in the table below is not matched to the principle behind its working?
So before you do that question, Felix, before you do that question, you have to tell us the weather instruments that we are having, the ones that are there, and their principle. What is principle behind this working? What is the meaning of the word principle?
I don't know.
Okay, who is helping? Who is helping Felix? Can you mute? Ninel, can you help Felix?
Yes.
Can you help Felix?
My answer is boy. No.
Exact question. You people, you have to know when you are answering a question.
Continue.
When you are answering a question, I have already said, first of all, know what is it that we are talking about. The question is asking very well the principle behind what? Behind the weather instruments. So you make sure you know, first of all, what is the meaning of the word principle? What is the meaning of the word principle? So we go to the weather instruments. So this instrument number 1 is a rain gauge. What is the principle under which rain gauge works? Who can answer that question? Principle under which the rain gauge works?
Liquids occupy space.
There was a girl who was talking. Mute, Levi. There was a girl who was talking. Who was she?
Yes.
Oh, Fethop. Okay. Fethop?
No, it was not me.
Okay. Who was she?
It was Mariera.
Oh, Prince Mariera. Tell us, what is the principle? Rain gauge work under which principle?
Liquids occupy space.
That's the principle number 1. So rain gauge work under which principle? Principle that matter occupy space, because water will enter inside this collecting jar or the measuring cylinder. So the water will enter here. So liquid occupies space or matter occupies space, measuring the amount of rainfall. Is that correct? So if it is measuring amount of rainfall, it is also, the unit here is also millimeters. So it is using the unit millimeters. So those are the 3 things you need to know about rain gauge. Let's come to wind vane. Who is speaking wind vane? Principle under
occupy space.
Air in motion.
Who is that one? Who is not? Melissa?
Olivia.
Yeah, correct. So this one is talking about air in motion. This thing is going to move. The arrow points to where the wind is blowing from. The tail point where the wind is going to. That is wind vane. Windsock. Who's speaking windsock?
Jami. They occupy space.
Say your name.
William.
William, okay, continue. You know, when I'm in presentation mode, I might not see you.
J occupies space.
Air occupies space. That one is for windsock. Air occupies space because the wind is going to enter here and the sock is going to either be straight, and then where there's no wind, it goes down. So that one is air occupies space. Thermometers, the 2 of them, the wind, the air, and the liquid thermometer. Who's speaking that?
Jami.
Yeah?
William.
I've said you say your name.
Olivia. William.
Olivia, correct?
Air thermometer, expansion and contraction of air.
Expansion and contraction of air. And I hope everybody is writing these things. Those are the principles. What about liquid thermometer?
Expansion and contraction of liquids.
Expansion and contraction of liquid. So air expand when heated, contract when cool. Liquid expand when heated, contract when cool. So those are the principles of the instruments that we have. So the question is, which one of the following instruments in the table below is not matched to the principle behind its working? So what are you going to pick? Who's picking?
Thermometer, expansion and contraction.
No.
Why have you left windsock?
Windsock, the principle is air exerts pressure.
No.
No.
Cha. Melissa.
Melissa, correct?
Cha, the answer is windsock, because the principle of windsock is air occupies space, not air exert whatever pressure.
Okay, so who said the answer was A?
Juanita.
Juanita, you did not read the word note. So that means anytime we are answering questions, I must read sentence by sentence until the last question mark, so that I know what the question is asking. This one is not, meaning all these ones are correct. Thermometer, expansion and contraction, rain gauge, liquid occupied space, wind vane, air in motion. So the one that is wrong now here is windsock, because air exert pressure is not for windsock. Windsock is air occupied space. Understood, everybody?
Yes.
Correct?
Yes.
Sarah? Other
Yes.
question number 3?
Yes.
Which one of the following weather instruments does not work on the fact that matter occupies space?
Move very fast, Sarah. Now that we have discussed all of them, If you need help, just tell us. Olivia and Melissa, mute. I will not tell anybody to mute. I will be removing you. You'll find yourself out of class if you have not mute. Ninel, can you help? Sarah, do you need help or you are continuing?
Pardon?
Sarah, Can we help you, Sarah?
I'm not sure.
You are not sure. But if we can just look at this question, Sarah, the question is asking which one of the following weather instruments does not work on the fact that matter occupies space. Remember, we have talked about the principles. So you check the rain gauge. How is rain gauge working, Sarah? Rain gauge, we have already said that the water will enter inside this collecting jar. True or false?
True.
That one is matter occupies space, because that water must enter, the rainfall must enter inside for us to measure. Then we come to the windsock. For this sock to go up, air must enter inside it. True or false?
True.
Correct. So that one also works in the principle that matter occupies space. What about the liquid and air thermometer? For the liquid and the thermometer, liquid must expand for us to see that the ink moving. The same applies with air. The air must expand. So there must be something that occupies space for these things for us to know the measurements, to know how hot something is or how low the temperature is. So according to me, unless somebody tell me something else, in wind vane, there is nothing we are measuring. We just show the direction. You just tell us wind is going towards east, or wind is going towards west, or wind is going towards south. So I don't think if the wind vane works under the principle of matter occupies space, unless somebody's having a different opinion. Is there anybody who's having a different opinion?
No.
We are okay there?
No.
Okay, so we are clear. Thank you very much. So let's say Ida, pick number 4.
A jar used for measuring rainfall should be I think narrow.
Reason?
Jar for it to have the correct measuring scale.
Now you see, in our mathematical knowledge, we said that we have the conversion units. Who can say them, those units that we normally use in mathematics? Which ones are they?
Millimeters.
No, we start with the biggest. You don't know from mathematics. Give me this. How do you master this one for mathematics lesson?
Kenya.
Kenya?
Kenya has dug many dams containing magic.
Many dams containing magic.
Excuse me.
So, I am mute. So what is happening here is, as we said earlier, that the units that are in rain gauge, these units here, 1, 2, 3, 4, 5, 6, they are in millimeters. This one here. So millimeter is the smallest unit of mass, of length. So if millimeter is the smallest unit of length, then what is going to happen is, if I have the jar, which is wide like this, what about if I have the jar, which is narrow like this? So a day in which we only have 2 mm of water. This 2 mm of water, if I put it here, you see where it is? Are you seeing where it is? You people, are you getting what I'm saying?
Yes.
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 Are you seeing where it is?
Yes.
But what about if I come and put it here? At least I will measure something.
Yes.
So this jar should be narrow. So write it. The jar used to measure rainfall should be narrow, but sometimes you also have to include this word narrow and long. So it should be narrow and long.
Now, like in the question, you had given choice A as narrow and choice dog as long.
But you know this one, they are very specific. You get this what they are saying?
Yes.
They are very specific. They are saying measuring rainfall. We are now measuring already. You know this Olivia?
Yes.
This jar here,
Yes.
we can use it. We can collect water, but now go and measure somewhere else. Are you okay?
Yes.
But if we are measuring at the same time, the one that we are collecting is the one that we are using for measuring, then it should be long and narrow. But now you see these people are very specific. They're just saying which one when measuring. Measuring one should be narrow. To measure what Melissa is telling us, smallest changes in the atmosphere, smallest amount of rainfall in the atmosphere. Tuko pamoja hapo?
Yes.
Correct. So thank you very much. Was it Olivia or Ida? It was Ida. So number 5. So I want these people who have not talked. You help me identify those people who have not talked. Kuna hii Melanie, pick number 5. Melanie? Melanie. Hiya. We don't have time, Melanie. Okay. Okay,
Yes,
continue. Read number 5, yes.
Which of the following statements about a wind vane is not true? The arrowhead, that's true. It should be placed in an open place. I think so. The arrow points to the direction in which wind is blowing to. Its compass point should correspond to the graphical compass.
Geographical compass points.
Yeah.
Which one is wrong?
Cha for me, cat is wrong. Cha, the arrow points to the direction the wind is blowing to.
So the arrow points the direction in which the wind is blowing to. That one is wrong because we have already said in question 1 that the arrow points to the direction in which the wind is blowing from. Is that correct? Is that correct?
Yes.
Correct. So that's correct answer. Anybody with a question there?
Yes.
Anybody with a question there? Okay. Christian? For 6?
Which one of the following statements about a windsock is true? A windsock shows the strength of wind.
So the question was asking which one is not true. So what is wrong with choice A? You have to be specific. What is wrong with choice A? Christian?
Choice A is anemometer.
Measure the speed of wind. Choice C?
Wind vane.
Choice D?
Yeah, this one works under the principle that air occupies
space. But the other one is working under the principle air in motion. Is that correct?
Yes.
Okay, so they don't work the same way. That's correct. Annabelle, pick question number 7.
The reason for using a biro pen cap as a pivot in the construction of an improvised wind vane is to make the arrow to rotate free.
Reason?
I'm not so sure about my reason.
Okay, so remember, the main word here is the pivot. So if the main word is here, the pivot is the turning point of a machine. So where it is turning point, that turning point is what is called the pivot. And therefore, we will put that one to enable it to rotate freely because when it is moving there should not be rough, should not also not be loose. So the barrel pen casing is helping it to rotate freely. That is correct answer. So rotate freely, number 8, we picked by Tanya.
The reason why colored water is used in the construction of a liquid thermometer is to for me it's make it visible.
Any person who has a different answer? Why is your answer make it visible?
No, because it's colored.
So when it is colored, it makes it visible.
Maybe. I'm not sure.
Maybe you're not sure. But now you see, the thermometers are these ones. These are the thermometers. So you look at inside this thermometer, there's that red thing. Are you seeing that red thing inside it?
Yes.
So it is enabling us to see how it is the temperature is changing So if I just put water or mercury, which is colorless, I will not be able to see. So we use colored water for easy for us to see clearly. That's correct, Tanya? Okay. Nyambura stopped. Juanita, have you said anything since we started this meeting?
No.
Oh, yes. Pick number 9.
Alice made a wind vane like the one shown in the diagram below.
Understand it well first. Okay.
The mistake that Alice made when making the wind vane was in
the wind vane you. So, Christian?
I'm saying you return the wind vane a bit.
Let me admit somebody here first. Okay. So I'm returning the wind vane, you?
Cha.
Wait, Christian, Jibu?
Cha labeling the compass points wrongly. Cha south is under north. It's not beside north. Cha it's northeast, southwest, not northwest, east, south.
Remember, we said that it should correspond to the geographical compass points. So we have west and south, north and east. But what about the nail? Are we supposed to use the nail? Are we supposed to use the nail, Christian? Because of time, yes. I think using a long nail, in the first place, we are not supposed to use the nail. So using a long nail is not a problem. Are you okay? Yeah, so we go with the labeling of the compass points. So choice D was the correct answer. Okay. Then Olivia.
Yes.
Pick number 10.
The diagram below shows a weather instrument.
And I hope you people, you are going through these questions, because when I ask you again these questions, you'll be able to get each and every one of them correct.
Question.
What is the diagram, first of all? You have to tell us what diagram is it.
Oh, it's a windsock.
Correct.
The instrument is used for measuring A, direction and strength of wind. That is correct. B, speed and direction of wind. Speed is measured by an anemometer and direction is measured by a wind vane. Speed and pressure of wind. Speed is measured by an anemometer and pressure is measured by a barometer. And D, pressure and strength of wind. Pressure is measured by a barometer and strength of wind is measured by a windsock.
Okay. So the answer becomes A. Very good. You are the person who have answered the question the way I want them to be answered. That's correct. Thank you very much for that. Shanice, number 11. Somebody's microphone is on. Christian, your microphone is on. Please mute.
Yes.
Shanice, number 11.
The diagram below shows an improvised weather instrument.
Continue.
Which one of the following does not affect the accuracy of the instrument? A, the diameter of the funnel. B, the diameter of the collecting jar. C, the distance between the markings on the collecting jar. And D, the material used to make the container. Child does not affect the accuracy of the instrument. Yes, is shall we?
If you need help, just tell us you need help. Yeah?
Very much.
The answer is?
Yes.
Sure.
Sure. The answer is D.
Shanice, you're saying D.
She said D.
Reason? Christian, why is it D?
I think the material used to make the container doesn't matter because it can be metal or plastic. Still, the amount of water that is collected will be the same.
Thank you very much for that. How will the diameter of the funnel affect?
It will collect more water or less water.
Correct. How will the diameter of the collecting jar affect? How will the distance between the markings of the collecting jar affect?
It will measure wrong.
Yeah, you'll measure wrongly. Thank you very much. So thank you for trying. I like that kind of trial. Then we have Joroge. That is Michelle. Pick number 12. Then Levy.
Yes.
Pick number 12.
The diagram below represents an improvised instrument. What could be used to measure the temperature? The working of the instrument is based on the fact that
Which one are you going with?
I'm not sure.
Not just try.
Sure.
You want to help Michelle?
Chef.
Levi, can you pick that question?
Sir, can you go back to the question, please?
Yes.
Choice A, liquids expand when heated and contract when cooled. Sir, can you go back to the diagram?
That's the diagram.
Okay. Sure, I think yes. Sure, because when like sometimes when these diagrams are brought in an exam, they usually like we usually see a drop of water on the narrow tube. Just so I think they heat the jar, then the liquid goes up, but I'm not sure.
You know what I want you to know, you guys, I want you to be very, very, very specific when you're answering questions. When you get a diagram like this in a question, the first thing I say it is that, can you first of all identify the diagram? Which diagram do we have right now in number 12, Levi?
Air thermometer.
Air thermometer. So if this is air thermometer, in air thermometer, is it the liquid that expand when heated and contract when cool, or is it the gases that expand when heated and contract when cool?
I think it's dog.
The gases. Yeah, the answer is dog.
The one that is going to expand is here in the thin walled glass. This thin walled glass, the air which is inside here is the one that is going to expand. Is that correct?
Yeah.
Yes.
And then when it expand, it will move that ink that you are saying inside the narrow tube down. And that's why
Yeah.
the scale of air thermometer, and I want the main reason why it is written from top to bottom is because this air inside this thin walled glass is the one that is going to expand. Understood?
Yeah.
Understood, Juanita?
Yeah.
Yes.
Ninel?
Yes.
Yeah, so if the air is, so that's the main thing. This one here, the air inside this thin walled glass is the one that is going to expand. And therefore, it will push that ink down towards the water. That's why the scale is written from top to bottom. For the liquid, it is the liquid that is expanding. Let me get, if I have a diagram for liquid. Liquid thermometer, this is air. Liquid thermometer is this one. For the liquid, you will find that we don't have that thin walled glass. We will only have this. So the colored water is the one that is going to expand. So when the colored water is expanding, then now it is the water which is expanding. That's why we say liquid expand when heated and contract when cool. So the scale of the liquid thermometer should now run from the bottom to top, not top to bottom. Understood there?
Yeah.
Correct. So
Sure.
this question here, so the answer become dog. Is that
Dog.
correct?
Dog.
Yeah.
Okay. Ninel, number 13. We are almost finishing. Ninel, number 13.
The diagram below represents a windsock constructed by pupils. A suitable material that can be used to make the part labeled Q is. Could you return the the choices? Polythene sheet.
Why not? Oh, this one is sheet of metal, not sheet of meal. Sheet of metal.
Oh.
Why not Manila paper? Why not piece of mosquito net? I am you. Nell mute. Somebody's talking where you are. Rachel. Eh?
Sir Christian wants to explain. Let him explain.
Okay, Christian.
Because it's the lightest material among them, it won't resist when the air is pushing it, unlike the metal and manila paper and the others.
And what about pieces of mosquito net? Pieces of mosquito net. They will allow air to pass. Is that correct?
Yeah.
Okay, great. Thank you very much. So let's stop from number 14 there with Rachel. Rachel, pick number 14. Rachel? Rachel is not there. Olivia?
Yes.
Number 14. You see now, you people, you are. That's why I normally want you to put your faces there. I don't know what you are doing at the back there when you are not answering the question.
This microphone, I'm trying to press, it's not pressing.
Okay. Question number 14.
The diagram below represents a windsock constructed by pupils. This is a windsock. It has a strong wooden wood. Which of the following is the reason why the instrument could not work? Go back to the diagram. Now go back to the choices. The sock is made up of a strong polyethylene sheet. So that's correct. And Q is larger than and P. A strong wire was used to make end P. Yes. A long, strong wooden pole was used to suspend the sock. For me, my answer is boy.
Boy.
Sorry, boy. Yes, and Q.
Why is it boy? And Q is larger than end P.
This is wrong. It should be end P is larger than end Q.
Yeah, according to the normal diagram of a windsock. Okay.
Yes.
So, like, if I look at a windsock here, this one here, this is end P, and this is end Q. Is that correct?
Yes.
So this one is supposed to be bigger than this. So this one cannot be bigger than this one. So thank you very much for that, and also for understanding. I want to take this opportunity to thank you very much for participating in today's lesson, and also plus the other lessons that you have been participating into. This marks the end of